Welcome and thank you for joining us today for 5 Best Practices for Application-Aware Network Performance Management in 2014. Our featured speakers are Enterprise Management Associates, VP of Research, Jim Frey, and Fluke Networks Managing Director, Product Strategy, Doug Roberts. Jim has over 25 years of experience in the computing industry, developing, deploying, managing, and marketing software and hardware products, with the last 20 of those years spent in network management. Doug has worked in the IT industry for over 18 years in various business development, product management, and innovation roles. Currently oversees the product strategy across enterprise, cloud, and service provider landscapes. Now I'd like to go ahead and turn things over to our first featured speaker, Jim Frey.
Thank you, Raleigh, and welcome everyone. Thanks for joining us. We have, I think, a very timely and appropriate topic to talk about bringing application awareness to the network management crowd in the form of AANPM and some best practices around that EMA has identified as part of research and ongoing dialogue with practitioners. So let's take a look at our agenda. We're going to first make sure everyone understands what we mean when we say AANPM. We're going to give Doug a quick opportunity to introduce Fluke and Fluke's role in this sector and solutions around that. And then we'll work our way through these 5 best practice areas. I will talk a little bit about what we found and what we see as drivers behind that, and what we see as key elements of the best practice. And then Doug's going to tell us how the Fluke solution is aligned to meet those as well. So let's jump right in. First off, I want to make sure we all understand what we're talking about when we talk about AANPM, or Application-Aware Network Performance Management. EMA has been following this sector for many years. Actually, all 5 years I've been with EMA, I've been driving coverage of this area because I see it as so important to the future of how network management and network performance monitoring evolves to meet the needs of integrated management. So really what it is taking advantage of that perspective from the network. You know, the network is so important. It delivers the applications that the business runs on, right? It delivers the applications and the services that allow customers to interact with business today. So the network is really an essential piece of the infrastructure, and it provides a really unique and valuable viewpoint to understand how those applications and services are performing. Therefore, really, this is a technique that lets you see business activity and business priority and organizational priorities from that network perspective. So it really is a tie-in point. You know, managing the network is an important set of disciplines to understand if the network is stable and performing as an individual technology component, but this is how we figure out how is that network actually delivering those applications. So we see that as a really important piece, by the way, as I mentioned, to making the shift that a lot of organizations are trying to do, where they're realigning their IT resources, in particular in operations, usually first, towards more service orientation, more application orientation, because they're realizing that's the rallying point of all IT. That's the key value that IT delivers to the organization. So everything needs to be lined up around that, and this is the way we do that from the network side. So I want to talk a little bit about the continuum here. There's sort of a number of related and similar technologies, and we're going to talk specifically about what makes AANPM from an individual technology perspective as we go through our best practices. But I want everyone to appreciate that there is this sort of continuum in network performance and application performance, visibility, and monitoring. At one end are the old traditional approaches that we would call NPM, and those are techniques that look specifically at network devices to try to find out how are those devices behaving. Are they healthy? What volume of activity is going through them? Maybe some rough utilization level aggregate metrics of what activity is going on. But typically, NPM does not give you direct insights into the applications that are running across those network elements. It's still important to know how the devices are doing and that they're healthy, but it doesn't give you that application connect-in. At the far end of the spectrum here is the more traditional APM, or application performance monitoring, whole set of tools that go after that value proposition and capability set. Those tend to be focused on an application by application basis. They tend to be instrumented by putting agents on the servers back in the data center, maybe some agents out at the remote sites or on an end user desktop to do some measurement of actual end user experience. they may give some indications that the network is a relevant part of a performance story for an individual application, but rarely do they have any details of, number one, where in the network problem might be, and number two, what else is competing for that network resource. And that's what AANPM can do by sitting right in between these two and looking at specifically how applications, which applications, and what all applications are traveling across the network links so that you can understand exactly what's going on. So hopefully that sets the ground of what we're going to talk about today. Doug, why don't you tell us a little bit about Fluke and what Fluke's doing in this area?
Sure. Thanks so much, Jim, and thank you guys for joining remotely today as well. So I add my welcome to the group. And I thought it would be best to kind of start with the end in mind in terms of describing Fluke Network's approach to this AANPM challenge, and the end in mind being, what problem are we trying to solve here? So undoubtedly, this picture looks pseudo-familiar to most of you on the other end of the webinar. Admittedly, it could certainly even be more complex if we were to add in, co-location or even cloud-based facilities or services down there in the data center area. But what this is meant to really do is to act as a template, a visual template of sorts, to depict the problem at hand. And the problem at hand in this case is that even still today, even with the clear and concise definitions of such measurement categories as application performance management, we still find that the network team is typically on the hook, or the epicenter, so to speak, as it relates to problem triage. So whenever there's a performance event, we still see that, the network is slow is the general notion. And so the network team, either engineering, operations, or architecture, is still on that proverbial hook to prove, number one, if it is or isn't, in fact, a network or infrastructure-related problem, and then number two, to provide those relevant diagnostic data sets to empirically show that, this is where that problem lies. And so that's the challenge at hand. And, the first part of this challenge is just understanding, first and foremost, how did that end user get into this infrastructure in the first place from a path perspective? It seems easy, point A to point B, but in fact we find that most of our prospects and most of our customers, even still today, until the implementation of our tools, really didn't understand the actual path that end users took across these complex infrastructures. And then secondarily, it's all the questions that are on hand in terms of, if it is in fact a network problem, how do we either exonerate that it isn't, or how do we prove that it is, in terms of, what is the capacity, what is the load, what's running across the infrastructure, what is the health of the devices, as Jim posited earlier, and then how do we evaluate the interdependent nature of both the application and the server infrastructure as part of this holistic delivery system that's supposed to be delivering this application or this service to the end user? Because in fact, it's an incredibly complex interdependent system that we have to monitor and measure to understand where the problem lies first. So we use a fancy term called problem domain isolation, and then effectively get to that root cause analysis data necessary to remediate the problem. But unfortunately, because of the complexity in the interdependent nature of these environments, the real question lies in terms of where would you begin? And unfortunately, what we found is that most of the individuals in the companies that we walk into initially, they have a multi-product, multi-process approach. So they have, the application team in silo over there working with their tools and processes and best practices. They have the network team and their silo and their tools and processes and best practices. And even the server and the data center teams, working again in a bit of a silo. So even if there's good foundational relationships in place between these teams, just the fact that there's these disparate tool sets in place creates remediation problems from a root cause resolution perspective up front. And so this is the real problem that we're trying to solve with this AANPM approach. And to do that, what we did was earlier last year, so it's barely a year old now, we introduced Visual TruView. And one would typically think, or initially think, that, okay, so with the combination power of some APM aspects and attributes with some NPM aspects and attributes, this has got to be a fairly complex system or a fairly complex approach, and it certainly could be if the problem wasn't approached in the right way. And so what we were trying to do with Visual TruView in terms of a product portfolio is build out a product where central themes of simple is better and less is more were key to the product success. And how this is accomplished is with this maniacal focus on the end user experience. Because at the end of the day, if you focus on the end user experience, that in and of itself will answer the questions of where and when you need to provide visibility across that infrastructure. So the key attributes of Visual TruView are certainly in the form of, first and foremost, it's very simple. So this is not a product that's going to take days, weeks, or months to implement with very complex processes and many staff members to install. In fact, TruView can actually be installed and operational in less than 30 minutes or 15 minutes in a lot of cases that we've seen with customers. It's also intelligent, and when we say intelligent, what we mean by this is it will automatically discover the application footprint that it's meant to monitor. So it will sit out there and it understands what web traffic or Oracle or Citrix or SQL or SIS types and kinds of applications look like, and it immediately begins to profile these applications, again, out of the box with no administration configuration required. And then probably one of the most important pieces to the solution is exactly what Jim was talking about in terms of the attributes of a true AANPM solution, which is what we're here to talk about today, and that's the fact that it's complete. Just a troubleshooting solution. In fact, it's both, and it's wrapped into a single product approach, and that is best represented in how the product works in terms of this end-to-end visibility and Simplified, because it sits out there and it monitors the health and well-being of our end-user community as it relates to end-user experience 24/7, and it presents that data through dashboards and dynamic thresholds, and then if and when there is a problem, you quickly can navigate that problem area with one click to understand who owns that problem, first and foremost. Is this a server, an application, or a network-related problem? And then once we've isolated that problem domain, how do I get to the necessary root cause information in terms of the conversation at hand, the packets attributed to that performance event, or maybe even the executed transactions that were at fault, depending on where, again, that problem lies. So this really outlines our approach to this AANPM problem. So with that said, let's get into the 5 best practices related to AANPM.
Yeah, thanks, Doug. So let's move ahead. Thanks for that intro. I think you're going to hear some of these themes come out in these best practices. Doug had a chance to peek ahead, and so I think he set himself up to answer some of these a little bit, and that's okay. But let's look at these. Now, these 5 best practices were developed as part of the ongoing dialogues that I have had with an EMA, with practitioners, based on the research I've done, based on the trends I've seen. And so we want to talk through each of them because I think they're all very important when you think about how you're going to approach this area, how you're going to find and implement a good solid solution for AANPM, and how you're going to take advantage of it. So the first one that we're going to talk about here has to do with multiple data sources. There are a number of different places you can turn to get good solid data that is going to give you this kind of visibility. And they really kind of fall into 2 categories. From the research we've done, it's either the most complete, perhaps, data source is looking directly into the packets themselves. Deep packet inspection, this is commonly known as. It's something that can be done in a backward-looking forensic manner, or it can be done in a live streaming real-time manner. In fact, it can be true real-time if you sit and listen to the packets as they go by. Now, this is the most complete story because you see absolutely everything when you look at the packets. But it's relatively expensive to do this, too. It's hard to pull packets from everywhere in your network. So very valuable, relatively expensive from a technology and an instrumentation standpoint. Complement that with things like flow records, and by flow records here we mean things like NetFlow, JFlow, SFlow, CFlow, NetStream, and IPFix, the standard IPFix. These are transaction or activity records that are generated by typically the delivery infrastructure, the network switches that are delivering the actual streams of traffic. So very valuable, less detailed because you're not actually seeing the contents of the packet. You're not seeing what happens lower down in the stack, so you don't see network errors, for instance, that you would in the packets. But it gives you a good record of exactly who's talking to who using what application and how much volume and so on and so forth. In fact, in that flow record area, recent new innovations in the templates around IPFix and the version 9 of NetFlow have opened up the opportunity to put much more detail into those flow records, including things like response time data that wasn't possible in NetFlow v5, or even you can even wrapper up a chunk of packets, a packet capture, and send it in a flow record. Technically, just about anything is possible. Any metric you could pull from a delivery device could be stuffed into a flow record using these new formats. We haven't seen a lot of people do that yet, but immediately there's already been extensions added and more advanced uses of flow records, and so it's becoming richer and richer as time goes by. Now, there's other supplementary sources that aren't usually the primary source of monitoring for this data, but they're helpful. Synthetic testing is one. A great example is something like IPSLA, and there are others out there too, but the goal here is to complement monitoring of real live data with samples that are put in place just to make sure that responsiveness is there, that performance is there when you don't have real traffic there to be measured. So probably not something you want to do a lot of, but selectively it's very, very valuable to give you that better sort of proactive data in case you're able to see things come up that happen that didn't get exposed because of real use. Log file analysis, growing interest in this. We've got some research around that says a lot of folks are looking at this. It tends to be something that helps reveal some of the details deeper down. Not so much used for performance monitoring, but it is really helpful in the troubleshooting process because there are things that are put into log files these days that you're not going to see through any of these other data sources. And finally, I'll mention SNMP from a number of perspectives, not only keeping a check and an eye on the health of the network delivery devices, the routers and the switches, but there's application-specific data that you need to retrieve from a lot of these devices using SNMP. So there are SNMP MIBs, for instance, like NVAR, which is a network-based application recognition from Cisco. There are multimedia-type specific MIBs. There are ABC, application visibility control data. These are things that you can pull out of network devices. You'll need SNMP to go pull that information out. So you got to keep that in mind. You have to have the primary data sources is what you're going to mostly build your story around and your approach around, but these others are helpful as well. So Doug, with that, can you tell us a little bit about what's going on with TruView and how you're covering multiple sources?
Yeah, exactly. So, to kind of go back, rewind the clock a little bit, if you guys remember this slide from the introduction of TruView, down there at the bottom, we really didn't exploit or talk too much about that complete nature, but, we spoke a little bit about monitoring and troubleshooting, right, covering the network and the application fabric. But the key component here, or the key driver here, is exactly what Jim's talking about, and that's the need or the requirement for multiple data source support. So I oftentimes tell, prospects that, if you ever have a vendor that comes in and tries to push one particular data source on you and build that up as king of all data sources over any other, you should probably invite them to the door, because the fact of the matter is every single data source has its own unique flavor of visibility that it can provide, and it's really how we leverage that visibility in a use model driven way that in essence builds the fundamental attributes of an AANPM solution. So to look at this in real life from a UI perspective, here's the real key. There's tons and tons of solutions on the market that certainly are capable of taking packet data in or flow data. Jim mentioned, the need and the requirement for synthetic testing as an adjunct data source. I'm specifically using the term active test in this case, but I think we're directionally aligned in terms of, this is the ability to sit out there and monitor components and pieces and parts of the infrastructure, even in off-peak hours or non-production hours. So for that 24/7 round-the-clock visibility, regardless of whether real users are accessing these services and these applications. So the real key here, though, is the fact that regardless of the data source being used, you'll notice that the workflows are built around the infrastructure itself in terms of site performance or application performance or network or VoIP performance. So that's the real key here, is building use models and workflows that are patterned around the way you as the user think of your infrastructure. And it's very different. If I'm talking to an application developer, they're going to think in terms of lines of code and applications and services stacks. If I'm talking to a tried and true network engineer, they're going to talk in terms of subnets and network interfaces and routers and devices. If I'm talking to an operations individual, they're going to talk in terms of regions and sites. So everybody tends to think about the infrastructure in a slightly different way based upon their role and responsibility within the overall IT organization. The key here and the trick is how we leverage these individual data sources in combination of each other to answer the question at hand. And so to see how this works in real life is an example of, again, regardless of whether you enter the system from a region perspective or a site or a server or an application, or maybe even as granular as an individual user or device, it's as simple as plugging in. In this case, this is an example of a site. So I plug in Site A, I pull up a single dashboard view of Site A, and in fact, I'm looking at end-user experience or response time to and from that site, simultaneously looking at inbound, outbound utilization, as well as both the application and the individual conversation footprint of who's talking to who and what is the application and protocol footprint coming in and out of that site. So there's a singular story or a singular picture built around a single site. However, behind the scenes, what's unbeknownst to the user, unless you're the administrator, is the fact that there are multiple data sources that are feeding this single view of the performance of this individual site. In this case, it's the packet or that DPI level packet inspection going on that's rendering the application or transaction level performance information, whereas it's the S&MP polling that's rendering that in-out visibility into utilization. And then it's really those flow-based records that are feeding our ability to depict who's talking to who and what does that application and protocol footprint look like. So this is a real-life view of how not only do we consume multiple data sources into a single system, but most importantly, what do we do with that data and how is it correlated and aggregated together in such a way as to be meaningful to the end user whenever they're trying to solve a problem or answer a simple question related to capacity, performance, or load.
Fabulous. Thanks, Doug. So let's talk about number two. The next topic I think you have to consider is making sure that visibility is great, but let's make sure it's comprehensive visibility. We hear a lot of talking about end-to-end. A lot of solutions out there claim to be end-to-end. But interestingly, and I think this kind of ties back to Doug, one of those early slides you put up that shows the fact that not everything is in the data center. In fact, there's a lot of really important stuff in the data center, and this is a really good place to start with visibility. But the bottom line is, unless it's application-to-application communications, if there's an end user involved, they are not in the data center. They may be at a campus LAN nearby the data center. More and more likely, they're somewhere far away, and they are reaching that application across either a WAN link or across a general purpose internet access link, oftentimes from a mobile device. There are any number of potential additional factors, usually adverse, when you start looking at the big picture and try to sort out where the real problem is. So the point that I want to make here is that your AANPM strategy certainly can start with the data center, but you also have to account for, as best as possible, gathering performance data from the parts of the network that are beyond the data center, looking out into the distribution and access tiers, looking at the LAN. In fact, some of the research we've done has indicated that application performance problems, as often as they occur within the WAN, they occur within the LAN because typically of shared resource issues. And we'll talk a little bit more about this in subsequent best practices, but bottom line is unless you can see what's going on within the LAN on a remote site, you don't understand all the factors that could be contributing to an adverse experience by an IT end user. you can't see the other demands on that bandwidth either to the WAN link or even just in the local site. And so you really need to have visibility that covers all portions of the network if you want to be able to definitively identify the source of problems without leaving big question marks. The last point I have on here also, don't forget virtual networks. And the reason I'm calling that out is even within the data center, we are still undergoing a lot of stress and challenge about how we maintain complete visibility in the data center when the network itself is starting to become increasingly virtualized. And this means virtual switches, traffic that travels between VMs that doesn't leave a hypervisor box, the use of overlay virtual networks that's starting to gain some traction. These are all new constructs that you need to also be able to understand and include in your picture of understanding of how the network fits together and where the path might take any particular set of flows or transactions. Doug, why don't you tell us a little bit about what Fluke's been trying to do with respect to scope of coverage?
Yeah, absolutely. Thanks, Jim. And it's funny, you mentioned end-to-end, and, I think like, network performance and application performance, this premise around end-to-end visibility is probably one of the most overutilized yet underserved in reality terms that we see in the IT landscape. And, undoubtedly you've seen a architecture slide much like this, and I'm certainly not going to read through this as I'm using this just as an example, is that, this is what you typically see or hear from vendors, including vendors like us at Fluke Networks. But the real key here, and what I want to focus on particular to this end-to-end landscape visibility, is there's no question that we provide a deep level of visibility into the data center. There's no question that we provide deep visibility into the WAN, but the real question that's been at hand as of late is that last mile of visibility related to that branch office or that remote location, whether it be a campus-oriented building, an actual branch location, or quite honestly, it could be an individual end user sitting at their home over VPN, connecting into the corporate network. So the drawing itself really doesn't do it justice in terms of, there's a simple switch and a simple user. But in fact, these remote branch sites can be quite complex with local services and servers in place, the wireless infrastructure comboed with the wired infrastructure there. And so there's a myriad of issues that can arise at these remote branch locations. And again, it's really that last mile of visibility that we see that completes this end user picture. So one of the things that we've most recently done, and we're very excited about, it's part of the release this month, as a matter of fact, is we have actually integrated the story behind our approach to collecting this information. So this webinar is certainly not focused on some of our sister products, but we have a product known as the OptiView XG, and there's actually over 7,000 OptiViews that have been sold into the IT landscape over the last decade. So the product itself has a significant footprint out in the industry, and one of the key core competencies that this product provides is automated discovery and very detailed device-level information at both Layer 2 and Layer 3 boundaries. So all the way down to the individual end user, the printers, the faxes, the switches, the routers, the load balancers, the wireless controllers, and everything in between, including the servers and even virtual servers, as Jim mentioned, are part of that device discovery. So what we've done is we've now connected the two, both Visual TruView with this XG database, to provide a complete end-to-end picture. So it's one thing to talk about, response time from a remote branch office or a remote branch user. It's a whole nother thing to be able to physically draw a picture and represent the actual path that that user took to get from point A to point B, but most importantly is providing the necessary analytics along that path so that when you do see a red condition at a switch port or at a particular router interface, we can go in and quickly deduce whether or not this was a performance from a response time perspective issue, whether this was a load from a utilization perspective, or whether it's a problem with that device itself in the form of CPU, memory, usage, or I/O attributed to that particular device. So what we're trying to do is take very complex data sets that we've been able to accomplish and simplify by presenting the performance in a single graph, and now we're trying to up that game again and provide a simple and easy to read and understand picture of where these performance degradations occur and then mitigate those problems. And so the final piece that I'll just mention here anecdotally is virtual traffic visibility, because that is certainly a very hot topic in the industry. And Jim mentioned, depending on how the virtual infrastructure is set up and configured, there's a lot of lost visibility in terms of what does that intra-virtual traffic look like. And Jim and I have discussed this before, and perhaps we'll actually do a webinar at some future date just on that subject alone. Quite honestly, that could be an hour or 2 hour long discussion in and of itself. But suffice it to say that the virtual vendors as a whole, regardless of whether we're talking about VMware or Microsoft's Hyper-V infrastructure or Citrix Zen environments, a lot of these vendors are turning the corner in terms of providing inherent visibility by way of port monitors and spans and things of that nature, as well as even supporting things like flow exports. So for instance, both Citrix as well as VMware now support the export of both version 5 and version 9 flow records directly out of their virtual infrastructure, providing visibility. That doesn't negate the fact that there are still those circumstances and instances where that intra-virtual traffic we still cannot gain access to based on a version or a supported flow type. And this is where we start to look at and implement strategies such as virtual taps. So the same way in which we access packet level data on the physical infrastructure, we're now able to instrument the virtual infrastructure in very much the same manner to gain access to that packet transaction level data. So this is certainly one of those key attributes associated with, again, just accessing the right data first in order to build that complete end-to-end picture.
Thanks, Doug. Yeah, actually, it is a topic for another day. And the good news is the approaches that we're using now can be adapted to that virtual environment. But it takes a little bit of work, and you've got to use some slightly different techniques. And so we will definitely come back to that. So practice number three, let's talk about how best to take advantage of AANPM technology once you make the investment in it. It's actually got multiple uses. There's multiple ways you can use the data that you're going to harvest. Capacity planning, really important, in particular by being able to see exactly which applications are active in each part of the network. When you do capacity planning and you try to understand if you need to upgrade, you need to expand, you need to add more links, this is especially valuable around WAN and remote site connectivity planning. Looking at this data can tell you exactly what is driving the use of that network link. Which users, which applications, which activity, what profiles, what time of the day is it busy, not just in raw numbers, but in being able to understand which application types are driving the activity. Is it business critical? Is it not business critical? I wish I had a dime for every time I've had conversations around where plans were being made to upgrade a WAN link because of saturation, but when you went and looked at it with an AAPM microscope, you could tell, wait a minute, someone's doing backups during the day, and that's what's causing the slow response time for the end users that are trying to do their jobs. So just by better planning and understanding of the loads, you might have a different answer to your capacity planning problem. This makes that extremely clear by using this kind of approach. Other things, sustained monitoring. Doug talked about this earlier too. In fact, this kind of harkens back to one of his introductory slides. I'm surprised. I talk to a lot of folks that use these technologies, and most of them use them for point number 3 here, which is troubleshooting. And they're really good at troubleshooting because they give you the deep diagnostics, both historical as well as current, real-time, right now, what's going on, to try to get to the bottom of whether or not there are issues in the network and or with specific applications that are causing performance degradations and poor experience. But most of these technologies can also provide sustained real-time monitoring for supportive operations, and yet not a lot of folks use them that way. This is a great opportunity lost in some ways, and one that needs to be thought of up front as you're looking at this technology. Think about and take advantage of the fact that these platforms can and will track for you in real time what's going on so you can see what users are active, what applications are active, and where in the network. Doug, can you talk a little bit about crossing and covering multiple use cases from the Fluke perspective?
Yeah, exactly, Jim. And it's funny, you start with capacity planning because, when we talk about network capacity planning, this is actually a feature that we recently introduced into our AANPM solution. And oddly enough, it's actually one of the most popular and most widely used. And I think there's a couple of reasons for that. One is, as application fabrics get more complex and bandwidth utilization and pocketbooks are tighter, as Jim alluded to, managing our bandwidth is more critical than ever. However, the industry's approach to true network capacity planning up until this point has been quite a complex and, more importantly, probably for most enterprises, an expensive venture. And when we talk about the complexity side of that, most of these systems are very hard to implement. They require, nth degree of visibility into the infrastructure. And then, a lot of times it takes a PhD to interpret the regression analysis and the 95th percentile information provided just to understand what it really means. So the approach we wanted to take was to take very granular data. So in this case, this is 60-second burst information. So for every interface across the infrastructure, down to 60-second level granularity with no aggregation or roll-up, you can go in and get a quick pick view of your hottest or most heavily utilized circuits as compared to the least utilized circuits. So we use default buckets of time spent over 30, 60, and 80% of utilization. But even more important to this, with one click into those circuits, we can provide that visibility into both the application as well as the conversation footprint of what application and protocol mixed made up this circuit utilization, and probably most importantly, who, from a source and destination perspective, was comprising that traffic. So it's really network capacity planning simplified. But again, I think we were even surprised at the acceptance and the use model across the broad base of customers that we support for good network capacity planning, but most importantly, network capacity planning that everyone in the organization could understand. And then that really dovetails into, well, so if we're looking at circuits in this way, and if we're understanding bandwidth contention in this way, what about everything else? We talk a lot about, we use all these generic terms, network and application performance monitoring. So let's get a little more specific. Jim talked about specifically about this concept of sustained monitoring that leads to troubleshooting. So first and foremost, actually recognizing what applications and users are in play, but then more importantly, not only monitoring after the recognition of those apps and users, not only monitoring their performance, but where do we go whenever there is a red light or a yellow light indicating degraded or excessively degraded performance, and how does that lead into definitive diagnostics? And so, we've long since used, cute architecture terms such as 3 clicks to fix and things of that nature, but in reality, what this means to the end user is you need the ability to go directly from an SLA or a key performance indicator highlight of red. In other words, something is bad at this site or region or device or interface, and the ability to click into that one individual site or region or device or interface and immediately understand not only where the problem is, but most importantly, what contributed to that problem. So if it were an application response time problem or an application-related problem, how do we get to that one individual call, get, post, query that caused that alert or that alarm in the first place? And this is where we can drill directly into the transactions at fault. So in this case, we know it is that very specifically that one get HR ASP login shot request that experienced a 500 internal error. And not only that, there's a last mile to providing definitive diagnostics. And that last mile we talk about of providing definitive diagnostics is really in the form of reconstruction of that event. And this is where warehousing all the packets behind any performance event critical component of this. And so this really speaks to that sustained monitoring that leads to troubleshooting.
Great, thanks, Doug. So let's turn to number 4 out of 5. So the next topic I want to talk about is the fact that you really need to, and we've sort of led up to this in the way we've been talking, especially around capacity planning and troubleshooting and understanding the mix of everything that's on the wire. But it goes a little deeper than that. Not only do you need to be able to recognize everything that's on the wire, but then you need to be able to serve all those 3 use cases for any kind of data that you can. Now, you're not going to have every piece of data you need to get to the bottom, underlying details of how some applications function. That's the realm of APM or of some of the other tools out there around server or storage infrastructure. But from the network perspective, you would at least need to be able to recognize, characterize, and drill down as deep as you can in terms of the network behavior of any application that's riding across the wire. So the common ones that we run across, and our research, just recent research that I haven't published yet, revalidated this list. Number 1 actually was email collaboration. So this is the most commonly present, not necessarily the largest volume, most commonly present. But then a lot of web traffic or secure web traffic, custom applications in the bigger shops. You need to watch those. Those are oftentimes some of the most mission-critical applications you have, or the ones that are built in-house, the ones that are unique to your organization. Network services. Now, what I mean here by this are really critical, oftentimes very low volume, but very critical type services such as DNS. It's a great example. If DNS isn't working, this is a big problem. That means nothing's working. If Active Directory is not working, that's a big problem. Low-level services, they're part of the mix. When they're not present or the responsiveness is bad, which you will see with these solutions, then you got a problem, and you got to jump on that. Let's talk a little more detail about VoIP and video, because these often get left out of the story. VoIP, video, there's multiple forms of video, even things like another one that's not on my list here, but I'll call out is VDI, virtual desktop infrastructure. These are all special types of traffic that tend to have very low tolerance for latency and for packet loss. VoIP in particular, it can handle a certain amount of latency and jitter and loss, and then it becomes degrades to a point where it's not understandable. Video, if it's streaming buffered video, it's pretty flexible. But if it's live video, video casting, video conferencing, that's a little less accommodating. And VDI, like I mentioned, didn't put it on this list, but that's the least accommodating of loss and latency. So these are the kind of things you need to be able to see besides most of what the traffic is going to be in terms of volume, which is probably going to be web traffic, email traffic, other custom application traffic. You need to be able to drive into these critical communications technologies that are all converged and traveling over that same network wire. Take advantage of that viewpoint, be able to look into them all. And I know Fluke has done some special work, for instance, around VoIP. Doug, why don't you tell us about what you're doing with respect to adding that visibility for VoIP?
Yeah, sure, Jim. And it's it's funny you mentioned. I love the premise of covering everything, and we often get that question because there's so many specialty tools in the IT industry as a whole that are web focused or database centric or even VoIP and video specific. So it is important to know that a key attribute of any true AANPM solution is out-of-the-box functionality for web-based monitoring, database, SIS, as Jim mentioned, VoIP, video. I mean, there's just a multitude of different applications and service types. So there's really 2 kinds of approaches that we view in terms of covering the entire landscape of application traffic. One is certainly a focus on VoIP and unified communications. So if you think about VoIP and UC as a whole, just like with transaction-based applications where you go from a global footprint of monitoring, when things are bad and drilling into the transaction at fault, voice and video are relatively the same way, but because they're so sensitive to factors such as latency, jitter, packet loss, and all these other factors related to network performance, it's important to monitor them in their own respective way in terms of, for instance, if we talk about a VoIP call specifically, it's all centered around the MOS score, or the mean opinion score of what did that end user experience in terms of quality? And if the quality of that call was poor, can we effectively draw a picture and quickly pinpoint and identify what degradation factor was the greatest contributor to that poor call quality, whether it be jitter, packet loss, or latency? But then most importantly, just like with every other application type, do we have the relevant diagnostic data in the background to where once we do identify what the problem is and the chief contributors to that problem, can we reconstruct that event as it actually occurred on the wire? And that's exactly what we're providing through the packet warehousing behind the scenes. And you can even go as far as to physically play back a video stream or physically play back the VoIP call as it transpired on the wire. So again, key critical visibility, but the key here again is this needs to be out-of-the-box functionality and not something that is a specialty add-on or an individual tool that is a component to your overall strategy. The second thing I just wanted to briefly touch on, and this really falls in line with the premise of being able to cover everything all the time, everywhere, is we're starting to see a pretty dramatic shift in some of the applications and services that even enterprise customers access are now co-located or in the quote-unquote proverbial cloud. And we see this in the form of SaaS-based applications or even hosted VoIP for some organizations who either have a small subsegment of VoIP users or maybe the organization itself is not large enough to support an in-house VoIP solution, so you get it from your provider. So the ability to provide availability and performance insight detail for even your co-located, or I'll use the term cloud-hosted applications and services, is a key critical component to covering that entire landscape as well.
Okay, thanks, Doug. So let's do number 5 here. Number 5 is, we should have done this as a top 5 list. That would be fun. Number 5 is taking advantage of this data and sharing it. There's tremendously valuable operational intelligence and planning insights that come out of these systems. But it's a real shame if you're not taking full advantage by sharing that information with other parts of the organization. There's a lot of folks I talk to, unfortunately, that keep this to themselves. They use it to make their own jobs more effective and more efficient, but then they don't take care of or don't take advantage of the opportunity to share that application-oriented insight out with other teams in the organization. So some things you can do in particular and things you should look for, and we have found have really served some additional value, is setting up sustained monitoring and setting up performance alarms, especially on key mission-critical applications, key performance indicators such as response time, looking for errors that you can catch through these systems as well, setting alarms forward so they can go into this to the basic operations center, the main console. Take advantage of that. It's there. These guys, for instance, Fluke has solutions that do automatic baselining, so you won't get a lot of false positives. But that's really important in terms of getting the early indicators that give you a chance to be proactive as opposed to being, and you should also do this and expect this, being able to be efficiently reactive. Proactive opportunities come out of setting these kinds of alarms so that you can recognize problems when they have reached a level that have not yet started to impact the end users. Got to use the alarms for that. Using constituent-based reporting, what I mean by that is there's a lot of folks out there. Let's use VoIP as an example. You may have a VoIP team who is really looking at keeping on top of the VoIP infrastructure, supporting the desk sets that are on the people's desks, supporting the soft clients that are out there, supporting the back-end call servers and gateways. And they may be very interested in understanding how overall VoIP services are looking and where there are choke points or problem points. Well, that information's in AANPM systems, but you'll want to set up reports that show just that view, just that data, the data that the VoIP team cares about. Most platforms can do this for you. Lastly, shared consoles, and this is where it really starts to get the most rich. Taking the dashboards, the kind of things you've seen from Doug here, or the real-time views, the specialized, customized views around certain problem areas maybe, or certain areas of constant concern that you want to keep an eye on, and making that available via the web to multiple users. So you can either share during a troubleshooting process, or just provide a good status update of performance from the network perspective around key important mission-critical applications. So I know Fluke's been doing a lot of work in this area. Doug, can you tell us a bit about how you're doing that specifically?
Yeah, exactly, Jim. And this is actually probably one of the biggest areas of value that our customers have recently seen or certainly used as a purchasing criteria related to the overall value proposition of, whether to implement an AANPM solution or not. And that is in fact built around this premise of, can this data be effectively shared across the organization? And there's really multiple places. If you start left to right, there's this premise around the CMDB and configuration management and, device management as a whole. And in fact, if one of the attributes that Visual TruView has is it naturally discovers automatically the application and server footprint out there. So the ability to reconcile these databases with an in-house CMDB is actually quite easy. And it's quite easy through the use model of this Connex Web Services. So we have a Web Services API called Connex. It's part of the product. It's not an add-on or an adjunct. It's just there. And it effectively allows individuals to make web-based calls into our database for a myriad of different types and kinds of information, whether that be configuration-related information, performance reporting information, or event and alarm-based information. So whether we're looking to feed analytics to a higher order executive dashboard in terms of dashboarding, as Jim alluded to, or whether or not we're looking to feed detailed alarm and event data to the notification by way of the help desk or the service desk. Again, the beauty here is this is regardless of the vendor used to manage those help desk and trouble tickets, whether it be, typical ones we see in the industry quite a bit, or IBM Tivoli and Remedy, or, there's been a big push to the cloud as of recently, and that even includes operations such as ServiceNow and other organizations and applications like that. So this is a key critical component to be able to provide that configuration, that reporting, and that event alarm information to the appropriate third-party systems. Otherwise, the AANPM solution is nothing more than another siloed-based product that you purchased, which is exactly the problem we're trying to alleviate with this type of approach.
Thanks, Doug. So let's wrap it up here and get to save a few minutes for Q&A. Quick takeaways here. Hopefully, here's some reminders of the things we talked about. It's EMA's perspective here that application awareness and network performance management really has gone beyond a nice to have. It really is a must-have these days. In particular, to give you the data you need to be able to work around an application-centric operations model, which is where most organizations are moving, some faster than others, but it's a great way to keep the network operations team, network engineering team in connection with and relevant to that sort of movement and trend. Try to make sure you're as inclusive as possible. This comes to the data sets as well as the coverage of the infrastructure, because you never know which data set is going to give you the insight you need, and you never know where that problem's going to be. Make sure you take advantage and use all of the feature capabilities across all of those core common use cases, capacity planning, sustained monitoring, as well as the most common one, which is troubleshooting. And finally, make sure you've got all your applications covered, and make sure you share. Really, sharing is a good thing. And there's great data in these systems, and the more you share, the more value you're going to be able to deliver to the organization, and the more value you get out of your investment in these kind of tools. Rolly, I'm going to hand it back to you. I think we have time for just a couple of questions at this point, right?
Yes, great. Thanks, Jim. Why don't we start off with you? And Doug, if you have additional feedback you'd like to add, please feel free. The first question is, how much attention should be paid to QoS classes on the network?
Actually, that's a really good question. Not something we talked about specifically here, but really important sort of the next detail level down. When we talk about the different applications, and I mentioned the fact that some have different needs in the network than others, well, commonly what you're doing in your network is you're setting DSCP or some QoS classes within the network that low latency applications get the highest priority for delivery. So you have a VoIP class. If you have VDI, you may even have a higher priority VDI class. Well, it is very important, and you can see through these tools what is traveling within each of those classes. Really important to recognize, by the way, when you have something in a class of service that shouldn't be there. Let's say you have some web traffic leaking into your video conferencing class of service. That's not a good thing. It means the web traffic is now starting to eat up part of your dedicated bandwidth. So that is very important. It's quite common within these tools. I'll let Doug talk about how that's supported within the Fluke solution.
Yeah, I mean, when you talk about, class of service, I couldn't agree more on the importance of doing it. The real question is to what level you provide that visibility, because as most of you know, precedent setting and class of service configuration is actually a pretty dubious task these days in terms of just, how granular you can get in the priority settings. And, again, we have access to stuff like TOS information or, diff-serve code point information out of flow records, but it's important to understand, how that traffic is flowing and what traffic is sitting in what class and what queues, and whether or not it's appropriate within those queues. And we do that by monitoring things like violation rates, across classes. And there's a lot of very granular data available. So one of the things we do, I'll specifically note Cisco, for instance. So we support the CBQoS, or the class-based quality of service MIB, by which you can go into any layer 3 device and in effect pull the number of violations attributed to any particular queue or class of service that is transporting that traffic. But again, an incredibly important part of this approach and the solution.
Great, thank you both. Let's just take one more question. Jim, can AANPM help me understand if performance issues are app-related or due to infrastructure?
Well, hopefully we answer that today, and I think the answer to that is a clear yes. It certainly is going to help you triage and understand if the problem is most likely within the application or back in the data center, at least track it back to the application tier, the application servers. Could be a server problem, could be an application design problem. Actually, the interesting thing about an AANPM viewpoint, especially when you're looking at the packet-based inspection approach, is you can see the actual structure of how applications communicate between the end user and the back end. And many times design flaws can be revealed just by looking at that. So there's a lot of indicators you can get, first of all, on a triage level, and second of all, many times really valuable information that's definitive in the process of troubleshooting an individual issue that can and very oftentimes is related to the application design itself. Doug, any other thoughts on that front?
No, I think you covered it.
Great. Thank you, Doug and Jim, for taking those questions. And I wanted to be sure and thank our audience for taking time out today to attend the webinar. Please, thanks again for joining us, and enjoy the rest of your day.